So, what do we do to actually get data out of a relational database? Well, that's where this whole SQL thing comes in, the standard query language. What do we mean when we say the word query? Well, a query is just a question. It's a question to the database, and the database is going to answer the query with data. So a query is an attempt to retrieve data. We always like to pose it as sort of a question first, and then the database will provide you the answer in some form or another. A query language, well, it's just a way to describe that question that the database understands. It doesn't speak English, though you'll see SQL is actually pretty close to English. And so we have to have a formal structured language for it. What does this mean? Yes, we have one more language to learn here. Now this is going to be a really easy one, and one where I'm not going to expect you to commit things to memory. Rather, you would sort of build it up dynamically and go look up the sort of definitive answers of it. Rarely will I have you actually pull SQL from your memory, except when it's really super simple. So don't be worried about throwing one more language in there. Ultimately, what we're doing here, SQL is a good candidate for the first kind of query language to learn because it's very natural. That was part of its design goal, to look like plain old English. It's also a good one because it is a standard. It is implemented by almost every relational database out there. And it's designed specifically for relational databases and to deal with the peculiarities that come with searching one and dealing with multiple tables that are related to one another. So really, we assume the database exists. It's already set up in the database system, and SQL is going to be our way to get at that data. This is how we will engage everything in this class. You will not be making databases. You won't need to worry about how to actually design a schema. That's something you would learn in a database class. You won't have to worry about how to set up the actual database engine, which can be very complex and work from different places, to tell it which ones are the primary keys, which ones are the foreign keys, and all that kind of nonsense. All of that's going to have been done. Instead, we're going to really be engaging it here at the SQL level. So this is where you really need to pay attention to the content for this course. Now, I think the best way to learn SQL is to just see some of it first. So let's start with that. We're going to assume that we have this database over here, which is set up with these 4 tables, and these 4 tables are going to encompass those 4 entities that we already talked about. And you already sort of understand how they're related to one another. What's some questions we could ask about this data? Well, first, what data is in the student table? That's a question we could ask. Now, of course, it's printed right over here to the side, but assume you didn't have that. It's just stored in a database. We're going to ask the database that. We'll say to the database, what data is in the student table? Here's what that looks like in SQL. I say select star from student. Select is the verb that tells it what you're trying to do. You're trying to select things, aka retrieve something. Star says what you're retrieving. In this case, everything. I want to see everything. Then from, and the table you want it to come from. In this case, student. It always has to be from some particular table. And initially here, we'll only do that from the tables that exist: student, grade, course, or teacher. So you could replace student with any one of these 4 tables, and you would see everything in that table. This would give you back every single row. Basically, it would give you back exactly what we see right here in the form of the student table, ready for you to do with as you see fit. Now that's a bit of a contrived question. Let's try and think of a question that's a little more, realistic, something you might actually ask a person. So, what are the students' names? That's something you might reasonably ask. Say you're a teacher at the school, you'd like to know who all is here at my school. Enrollment at this particular school happens to be really small, so that's not an unreasonable question. How would we get that? Well, the query would look like this. Select name from student. Now remember, previously we had a star here which said select everything, but I probably don't care about something like ID. ID is important to the database, but rarely are those IDs actually something that we use too often. And so instead, if I'm going to talk to these students, I'd like to know their names. And so I would say select name from student. That's going to give me back these 4 rows with only one column, the name column, and that's it. So I'll see Bart, Milhouse, Lisa, and Ralph. Email and ID will not be there. So this allows me to be more specific about what I'm selecting. Back in the previous example, we selected everything. The asterisk does that for us. Here, we're selecting one very specific thing. And you'll see as we move along, we can also select multiple things. We just list them separated by commas between select and from. And let's think about some other questions we could ask. What is Bart's email address? Now, What's different about this? Well, in the previous questions, we just said, give me everything, give me all the names, or give me all the data in the student table. Here I want something that's specific to a particular instance of an entity. The entity is student, and the specific instance is Bart. So I need to know what Bart's email address is, not all the email addresses. And to do that, we're going to have to expand our language just a little bit. The query is going to look like this. Select name, comma, email, so here I'm selecting two things, from student, where name equals Bart. Now Bart is a string, so we would put it in quotes. And you'll see a lot of the things that we're going to be selecting in here will wind up being strings, just like in JavaScript where almost everything ends up being a string at the end of the day anyways. So what's different here? Well, previously I selected name from student and that was it. Now I have a where clause on the end, and the where clause allows me to be more specific about the data I want returned. I want to make sure that you give me the particular row, the particular instance, where the name equals Bart, and only that one. Now, if there were multiple Barts, I would get all of them, and maybe there's more than one Bart, but they have different last names. That's entirely possible. In that case, I might need to specify both first name equals Bart and last name equals Simpson or something to that effect. But in this particular database, we don't have to worry about that. Now let's think of another question that we could ask that would be similar to this. The question is a little more complex. Who taught CS142, so Computer Science 142? I want to know the teacher's name of who taught that. Well, I know that data is more or less in the course table. I have the name of the course here, and here's the teacher ID. So I could make the query like this. Select ID, comma, teacher ID from course, where ID equals 10,001. Now in this case, I also had to know that the ID of Computer Science 142 was in fact 10,001. So what is that going to give me back? Well, in fact, it'll give me back the teacher ID, 1234. Now, that's maybe okay if you're a computer, but it's a little confusing to a human being. The real question probably was, what's their name? Now, I've focused in on just the course table and the teacher table here, because that's all we need for the moment, and I'd like to keep the clutter away. So we're trying to figure out who taught CS142, and we want their name, not their teacher ID. Well, unfortunately, we have a problem. And this is what happens with relational databases. The course itself is in the course table. We already know it's course 10,001, so we can select it that way. But there is no column for the teacher's name. I have the teacher's ID, but not the name. When this happens, we actually need a different view of the data. We need a different perspective on it. What we'd like to do is take these two tables and combine them together so that name is inserted, or excuse me, teacher's name is inserted into the table. And in doing that, we would create a way that we can actually have a column with the information we need. This is what you have to do. Every single query is going to give you back a table of some kind. That table might be the entire table, like we saw in the first question. It gave us back the entire student table. It might be a reduced form of an actual table. In this case, we need to build a table that has the information we need. We do that with a join. And this is where SQL starts to get a little bit complicated. So we're going to select the ID, the teacher ID, and the name from course. Well, that gets a little more complicated. Name here is in fact there as this, but it's also over in the teacher table, and teacher ID is there as well. What I really want is the name of the teacher. So in order to do this correctly, I actually need to create a whole new table, and so I'm going to take course and I'm going to join it with teacher. So we have this new word here, join, and then the other keyword on. We're going to join course and teacher on ID equals teacher underscore ID. And so this would allow us to join these two together. Now by joining these two, I've actually created a whole new table where these two are merged, where the information from teacher table has actually been brought in and inserted into this table. This table doesn't exactly exist anywhere, but we can see what it would look like. The table would essentially start to look like this once we've joined course and teacher. There's now a new column called name that includes the teacher names. And how did it figure out what goes where? Well, it used the on part of this. Everywhere that the ID from the teacher table equaled the ID in teacher ID, it pulled in the extra information. And if there had been more things than name, we'd have more columns added on here. And so it matches the two things we tell it to, the teacher ID and the teacher underscore ID, and then pulls in all the other information based on what that equaled. This is a virtual table, and it's often called a view of the data. Now, I will caution here, view tends to actually be something technical that can be part of the database itself. But technically, what we've created here is a view. This is a different way of looking at the data that doesn't exist. It isn't actually stored in the database, but it is able to be created with our query language. So that's the simple idea. Make sure you understand exactly how the join syntax work. I'm now drawing from course joined with teacher, and I do this on a particular element. Now, when I ask for 10,001, I'm going to get back this row right here, which does include the data I need, the name of the teacher. Now, you may have noticed something. One thing that often happens when you join things together is that we suddenly wind up with an ambiguous situation. I even mentioned that we have two things called name now. How does it know which is which? Similarly, we had two things called ID. This is a real problem with our query. There's three places where we have ambiguity. We said select ID, and we selected name. Well, which ones are we selecting? Do we want the ID of the course or the ID of the teacher? Do we want the name of the course or the name of the teacher? That's a problem. And in fact, this query, because of that, would be incorrect. It would be ambiguous. Same thing here. When I say join on ID equals teacher ID, well, which one? Now, it may be obvious to us as human beings, but of course, it's never obvious to the computer. There's also a third place where the ID is ambiguous. All of these places really need to be made unambiguous. How do we do this? Well, we prefix it with the name of the source table. So we say teacher.id. And over here we say teacher.name from course. And then when we join them together, we have to say teacher.id equals teacher underscore ID. It's a very nice way to do it, I think. And you'll find I always name my foreign keys like this in order to get this kind of simple syntax. There's actually one other place where we're missing it. We'd really have to say where teacher.id, where course.id equals 10,001. So this is a mistake here. There should be course.id as well. So as I mentioned, joins are where SQL becomes complicated. Prior to that, it's all pretty straightforward. Make sure you spend a lot of time with the reading on joins. Just how complicated can they get? Well, we only joined two tables here. That wasn't too bad. Let's see if we can think of a question where we have to join a lot more. Here, what grades did Bart earn from Kerbapple? Well, if we go back to our original table, this is just the flat table right here, you can see Bart earned a B- from Kerbapple in Computer Science 142. We have another row for Bart, but that was from Hoover, not from Kerbapple. So that's the one grade we have that Bart earned. We can see that easily from the table. Unfortunately, we don't have that. We have to recreate this table. Well, how do we recreate this table? We join everything back together. The student with the course, with the teacher, and the grade. That is 4 joins. So, student.name and grade from student. Join grade on student.id is student ID, course on course ID is course ID, teacher on teacher ID equals teacher ID. So here's 4 joins in one. Student, grade, course, and teacher all being joined back together. And how do we identify it? Well, we say we want to make sure student.name equals Bart and teacher.name equals Kerbapple. What did we end up doing with this query? Well, gosh darn it, we ended up recreating the original table. The exact one. And here it actually has teacher in it. When we made that one before, we hadn't put the teacher information in yet, so that's in it as well. We've created this table virtually, which is better than actually creating it and storing it in the database. But this particular view of the information was needed in order to answer this question. What grades did Bart earn from Kerbapple? It's actually a pretty simple question, right? So it's a little disappointing that we have to create such a complex query to answer it. But this is how it gets to be with relational databases. Queries get ugly very quickly. By the end of this, we wound up recreating the whole darn table again. And that's a little disappointing. This actually becomes the impetus for why relational databases are now kind of on their way out. They get so complex, and they get to where, in order to answer a question, you're basically joining it all the way back into what it would have been if we'd have just left it in its raw form to begin with. So let's talk a little bit about the actual technical details of SQL. We've seen some examples here. Hopefully they're starting to make sense. But we can break it down now into what all the different parts are. First, with SQL, we have what are called verbs. These are the actual actions that you can do in the SQL. And they follow this pattern called CRUD, which is a really fun little term that comes from computer science. The CRUD operations are create, read, update, and delete. And many different systems will offer you the basic CRUD operations. SQL is no exception. Here, the CRUD operations are, respectively, insert, select, update, and delete. Insert creates data, select reads that data out, update is update, and delete is delete. Those just actually match their original ideas. So these are the essential basic starts of any query that you're going to do. Now, we're only going to do select queries. Insert, update, and delete are all insecure, and they're ones that we really would only expect you to get deep into if you were actually designing a database or trying to put new data into it, all of which is stuff that you can do in a more advanced course. So we're going to focus on select. The syntax of all four of these is a little different, so make sure that you've at least looked at how they work when you're reading about SQL online, but I will focus on select as the main one. You can then use modifiers inside of these. These all apply, in our case, to the select one. From tells it which table to get it from. Where allows you to specify criteria that will filter out rows, like we said, where name equals Bart. Join allows you to combine tables together, and on allows you to specify how to combine them. All of those modifiers are important for select statements, and that's what we're going to be focusing on. There's other things that you need to pay attention to as well. There's a couple extra modifiers that you can include that we haven't seen yet, but that you will see in some examples. First, it's distinct. If you put distinct at the beginning of, right after the word select, then it will look through your rows and it will remove any rows that are identical to any other rows. This makes your query take longer, but it also will remove redundant information, and that's sometimes necessary as you've joined together a new table. This is something you often have to do when you join or when you filter out and reduce something down. You also have order by. This allows you to sort the results. Again, your query will take longer when you do an order by. Order by normally goes at the very end after the where clause. You have some operators that you can use. These are usually used inside of where clauses, and allows you to join criteria together so that it must meet both of them, or allows you to specify one or more criteria that it should meet. If it meets one or both of them, then you're allowed to, then it matches the criteria. The last one is like, and that's really handy for a sort of fuzzy search where you want to say something starts with a word, ends with a word, or contains the word in the middle of it. It's very much a string matching kind of operator, and you'll see it's very simple and a very powerful way to search through, but of course it's also less efficient than doing it as a pure sort of equals. In addition, we have a few other really handy things. We have some math functions. This allows us to do really simple math right in line in our SQL. We can count the number of rows that are returned. That can be used actually for anything, not just numeric values. We can also look at all the values that are returned through all the rows and figure out which one was the smallest or the biggest, min or max, as well as compute the average of all the values together. These are often things that you'd just like to have really quickly, and so they're built into the query language itself. Now, you'll find pretty much every SQL implementation will support all of these, but many of them customize and support more than just these. But those are getting away from the standard. So these are things that you will need to be using in this particular class to answer some questions from time to time, so make sure you understand them and keep them in mind and practice with them.